All right, next you are building a rectangular chest, a little trunk here. You want the length to be 6 feet right here. You want the length to be 6 feet. You want the width to be 4 feet. So maybe you have a place in your closet, in your room where it's going to be stored and you know those dimensions. You want the length to be 6 and the volume to be 72 cubic feet. What should the height be? So, let's kind of work backwards. This is a prism. This is a rectangular prism. The volume of a rectangular prism is base times height. So I know the volume. The volume is 72. They gave that to me over here in the problem. I know the base. The base is kind of the top and the bottom here, the base. So the base is 6 by 4. If I do 6 times 4, I get 24. I do not know the height. That's what I'm trying to find. What should the height be? So to solve, I just divide by 24. The height should be 3 feet. 3 feet. Okay. All right, you are building a 6-foot tall dresser. You want the volume to be 36 cubic feet. Give some possible, what should the area of the base be? Give a possible length and width. All right, let's just try here. This is my dresser. Put some little knobs so you can open your drawer. You'll probably realize, especially in this chapter, not the greatest at drawing, but you are building a 6-foot tall dresser. So 6 feet is the height of this whole dresser. We want the volume to be 36 cubic feet. So volume equals base times height. The volume is 36. The height is 6. That was given to you. So this was given, this was given. Let's divide by 6. So the area of the base is 6 feet. What are some possible dimensions that we could do? So here's my base, or here's my base down here, if we want an area of 6. So we could certainly do 1 by 6, or we could do 2 by 3. I guess it depends on the situation. I think 2 by 3 would maybe make more sense, but either one of these would be acceptable. All right, number 6, and this is kind of the part that we grade out. That we'll go back to. Find the volume of the cubes. How are they related? So these are similar figures because cubes are all similar to each other, because each side is equal in length. All right, so let's find the volume of this little cube. Volume is base times height. So this is 2 by 2 by 2 because it's a cube. The area of the base, 2 by 2, is 4. The height is also 2. 2 times 2 times 2 is 8 centimeters cubed. And that's also why in math, that's where the name comes from, 2 cubed, 2 to the third, 2 times 2 times 2, side note. Anyway, so the volume is 8 cubic centimeters. Now let's find the volume of this bigger cube. So 6 by 6 by 6. Volume equals base times height. So 6 cubed, that is going to be 216 cubic centimeters. Now, this wasn't too bad to calculate these, right? 2 times 2 times 2 is not too hard to do, 6 times 6 times 6. But we want to see if we can find a pattern for how they are related. So let's think back to our similar figures, our scale factor. So how do I go from 2 to 6? The side lengths, how are they related? I would say the scale factor is 3. 2 times 3 gives me 6. So the side lengths are related by a scale factor, or K, of 3. How I'll highlight this, how are the volumes related? 8 and 216. How are those related? If I do 216 divided by 8, I get 27. So the volume of the larger cube, the volume of this cube, is 27 times as big as the small cube. So that is different than my scale factor of 3. But can we think of any way that 3 and 27 are related? If I take my scale factor and cube it, 3 cubed, 3 times 3 times 3, I get 27, right? 3 times 3 is 9, times 3 is 27. So kind of like when we talked about area and we talked about scale factor squared, for volume, we are taking our scale factor, K, and we are cubing it to figure out how the volumes are related. And last example. All right, let's kind of try to use that and look at example 7 here. All right, so cylinder A and cylinder B are similar. Find the volume of cylinder B. So they are similar. We know the volume of A is 45 pi. We want the volume of B. Let's figure out our K. So the radius, kind of like a side length in this example, is 3 in cylinder A, 6 in cylinder B. So ask yourself, what is my K? How do I go from 3 to 6? So hopefully you said 2. The scale factor is 2. 3 times 2 is 6. So how are the volumes related? So instead of having to like calculate all the volumes, pi r squared times height, blah, 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 let's take our scale factor and cube it. So let's do 2 cubed. 2 times 2 times 2. Please don't say 6. It is 8. So the volume of cylinder B, the bigger one, should be 8 times bigger. 8 times bigger. So if the volume of the smaller cylinder of cylinder A is 45 pi, let's take 45 pi and multiply that by 8. That is going to give me 360 pi. And I don't really need to multiply out the pi. I mean, I can if I want to, but I don't need to. I can just, basically I took 45 and multiplied it by 8 and I kept the pi. So that's actually, in this case, a little bit easier, I think, now that you know that pattern. So I am going to hop back for a simple, and this is kind of a composite figure that we are going to go over here. All right, find the volume of the concrete block. So you basically have this brick or this block, and then you have these little holes in it. So first, let's start with the volume of the entire shape of like the whole big prism, the whole thing, pretending that there were no holes in it. It's a prism, so let's do base times height. The base, again, for a rectangular prism, it doesn't really matter what you think of as the base. Let's just maybe say that the bottom here is the base in blue. So that's going to be 1.31 times 0.66. Then the height of the entire prism from base to base, 0.66. So I'm going to multiply all that out. And the volume of the entire brick, 0.57 cubic feet. All right, but we have these little holes that we need to kind of subtract out. So, and these holes, yeah, right here. All right, so I'm going to just kind of draw it down here, the volume of the hole. If you look at the base, it's kind of telling you the base, 0.33 times 0.39, and then the height is the same height as the whole cylinder. So I'm going to multiply that, and I get 0. Okay, and that is the volume of one hole. There are 2 holes, so if I multiply that by 2 or add it, the volume that I'm subtracting out of the 2 holes is 0.18. So if I take the big volume, back up here, the volume of the whole shape, I'm going to subtract out the holes, and the volume of this concrete block is 39 cubic hundredths. So I found the volume of the whole shape up here. I found the volume of one hole, I doubled it, and I subtracted. All right, so there was a lot. That's a pretty dense section, 11.5, so you can always reach out to me for help. The homework is on big ideas for the summary. What is volume? What is volume? I didn't really write that out, so I will say it. Volume is the space inside a 3D figure. So really important, how much cereal fits in the cereal box, how much oatmeal, how much soda. What is the volume? What is the formula for finding the volume of a prism? What is the formula for a cylinder? How are those related? It's not a coincidence that your textbook and that we chose to cover the volume of a cylinder and a prism in 11.5. What is K? How are the volumes of similar figures related and related to K or the scale factor?